Welcome back to the Federal Executive Forum on Federal News Network. We're talking about artificial intelligence and machine learning, and we were just going across the top line, state of the state. John, tell us about Aerospike. What is Aerospike? How do they fit into the ecosystem here? And what are you seeing across the community?
Yeah, it's a great question. The Aerospike is a database engine that makes a lot of AI and machine learning actionable. And we fundamentally are dealing with a problem set that's pretty unique. The internet essentially has scaled the issues around data and how to use data effectively in ways I think we all knew it was coming, but it's just hit us like a sledgehammer. And most organizations have a lot of data that's been collected over the years, and then they have data that's coming in the moment right now. And fundamentally, there's lots of different ways you can use data, but you try to extract information from it that can be slowly extracted, or you try to deal with data that's new and deal with it in real time. And the issue is going from the edge back to the core. And that's the issue that Aerospike facilitates. As it was mentioned earlier, you've got a huge ingestion problem. If you think about ingestion problem, one of the IoT applications we're working on deals with an ingestion rate of 12 to 15 terabytes a second. That's an awful lot of data to sift through. And fundamentally, you can use algorithmic decisioning engines, and their job is to decide what's the next best action. And we're talking about decisions being made in less than an eye blink. And for people who don't think in terms of milliseconds, an eye blink is 300 milliseconds. So you need to have a data engine that can basically handle transactions in microseconds. And that's just not where the technology's been. That's what Aerospike can do from the edge and back to the core. But some of the other issues that are being discussed today, it's very, very complicated to take some of the old technology that's good, combine it with new technology, and make the whole system fit together so you can improve your intimacy with your constituency, provide a better service, whether it's with the VA, whether it's Department of Defense. It really doesn't make any difference. So that's kind of where we fit in this.
Thank you, John. The volume and the speed that you're describing there is absolutely making my head spin. It's really, and you raise a good point about trying to take some of this advanced technology and merge it with the current technology and making sure it all comes together. Well, we always like to talk about a specific example. And Rachel, I'm going to ask you to give us a specific example over there at NGA. You already talked about some cool stuff that you all are doing over there in regards to something that's you're currently doing, something that's in the hopper in regards to artificial intelligence and machine learning.
Sure. So I'll go back to the example I actually referenced earlier, because I think it's a really great example of working in partnership, with industry and really applying some best practices to a problem set that is one that, again, as I mentioned, I think is not unique to us, and that is just the proliferation of unstructured text-based data that we all deal with on a routine basis. So the problem that I had referenced earlier is this responsibility that NGA has to update aeronautical publications. And just to give you a scope of what we're talking about, is information from approximately 200 foreign nation civil aviation programs. So we're not only dealing with text-based data in English, we're dealing with text-based language and occasionally in other languages as well. And like I said, that averages out to about 250,000 pages that our analysts had to review every month in order to make sure that there were no updates that would affect the safety of navigation, safety of aeronautical activity for DoD. DoD is responsible for doing this every 28 days, and it supports 13,000 aircraft. So the potential damage from getting it wrong is pretty significant. And as a labor intensive process, it's also ripe for potential mistakes. So NGA's AAA team partnered with Amazon Web Services to pilot a text extraction machine learning model to start automating this activity. And ironically, COVID kind of helped in this respect. Everybody was home under quarantine. We weren't operating our normal classified systems. And so we were really able to innovate by accessing technology, in an unclassified domain in a way I think perhaps we had not necessarily done in the past. And the initial pilot was really quite successful. It's continuing. We're looking at scaling at the moment to multiple other countries. We started with just a handful, and we're looking at something around 20,000 hours per year saved in analytic time. And something around in the order of millions of pages of text every year. So I think this was just a really great example of using an existing technology that was readily available in industry, that we could bring in and immediately apply within very rapid order. I want to say they went through the pilot and prototyping in about 6 months or so. And so we look at that as a good example of where we can save our analysts time to work on the things that are most important, and let the machines do the work that is more routine.
Right. Take the robot out of the human, right? And let the human do their thing. And it's interesting. The COVID, sort of play has really unlocked a lot of solutions out there. It's really fun to see that. My head's just, I was shaking my head. Just again, the volume of what you're describing there is absolutely incredible. Henry, how about at Cloudera? Can you give us an example of, a use case there that would be of great interest to the listening audience that you all have been involved in?
Yeah, one that I'm really proud of is our partnership with the Navy. We've been working closely with them for a number of years now on predictive maintenance for some of their airframes. And if you look at where we started, these aircraft have put out a huge amount of data all the time. And when that was first happening, a lot of the data was falling to the ground. It wasn't being leveraged for predictive analytics. It was for data science. It wasn't done pretty much anything. They would actually have people on, a private would come out and fill out a handwritten checklist, right? Did you do this thing? And the pilot says no, right? I didn't do that thing. And what we ended up doing was leveraging the data where we could actually see the banks and turns and things that were happening while the vehicle was in the air. And then what does that do to parts that are happening in the aircraft? And so instead of being down for a month at a time for maintenance, what we were able to do is leveraging the data, realize that, hey, in 2 months you're going to need this part so that we can keep that bird in the air. So instead of a month down, you're talking about a week down for maintenance. And those predictive maintenance use cases have been really successful. We're excited about what we've done with the Navy.
That's fantastic. You just collect this data and crunch it, and you start to see these patterns. And all of a sudden, these pearls of wisdom start to come out, and you can make really good informed decisions. It's a great use case. So Neil, how about at U.S. Customs and Border Protection? I know you have a lot of different activities. Give us one use case of something that you all are doing to keep us all safe.
Yes, sir, absolutely. Thank you. From CBP perspective, as I mentioned earlier, one of the pieces which we were not doing before was we're collecting a lot of data, but that data, as you said, is the kind of data we were collecting is changing, right? We mentioned about some of the NLP-based data, some of the data which was more video-centric data now, which we were not collecting a whole lot before. So think about some of the cameras and everything at the border, which we are collecting information from. So one thing we started to do, an example that I want to give you is that we started to annotate and tag the data now, so that we can look at the metadata on top of that and collect information and build some models on top of those of the data we have, so that we can figure out, okay, what is the, as to, I can't go into some detail, but I'm just saying is that we're able to assess things better moving forward. And also it kind of helps our agents and officers to look at certain peak times on a certain different time as to what that looks like. And it also, the thing is, this also plays into another piece, which is called the ethical data or ethical AI, which is also getting an interesting position within CBP. We want to make sure we do everything correctly, and think about biometric pieces, right? We're collecting biometric information. How do we make sure our biometric information is completely safe and and secure and things like that? So our models are built like that, so that whatever data we are collecting as of right now is mostly was pretty much transactional, but that is changing into more and more where we are using NLP, and we are also using video-based technologies. Other piece I want to tell you quickly, Luke, is another example we have is we're using also RPA, robotic process automation intelligence, so that one example where we think about if you have email and email, you run a bot on email, and you can actually bring all your common email, which you read a lot more, on top of your inbox, right? So which is helping our execs and other folks to take advantage of that. So those are a few examples we're doing at CVP, lots to go. And recently, as you know, the National Security Commission on Artificial Intelligence came out a final report. A lot of good information to read from there. We're learning from that and moving on.
Fantastic. Glad to see sort of the all of government coming together and getting all the great ideas and bringing them to the top, and some fascinating use cases there for sure. Nick, how about at Pure Storage? Can you give us an example of a solution that you all have been involved in that's really changed the game, so to speak, in regards to any of these agencies?
The explosion in biomedical research, patient care, and obviously disease tracking in COVID has significantly ramped up a lot of the data efforts, both on the cure finding as well as the patient tracking across the country. And this actually ties into obviously several of the agencies that are here on the call. We partnered with Health and Human Services, who reached out to us to try and help address the explosion in data growth that they'd had, both structured and unstructured, as they were trying to wrap their arms around what this disease was, how it behaved, unraveling its RNA, and then of course, how it was impacting the population. So when you need really fast, really powerful, scalable, dynamic data service, you have to start looking at newer technologies that lend themselves readily to those, volume, velocity, and variety challenges. And that is really one of the reasons why, solid state storage is absolutely critical to this type of endeavor. And again, it's data movement. You have to be able to integrate cloud-based data storage platforms, cloud-based data, I should say, with your on-premises infrastructure and seamlessly interchange that data back and forth. So we work together with Amazon on their Amazon Outpost solutions to be able to create an on-premises edge type computing capability, as well as shoring up the on-premises infrastructure of HHS to address those particular requirements, and then support the data integration efforts across agencies, not just integration, but data distribution. So there's a ton of customers for this stuff. So the data has to be able to move seamlessly from organization to organization, and it has to lend itself readily to the processing capabilities that those organizations have. So that's, I kind of like to think of what we do as we're the freight train of data. Mm-hmm. We're what gets it to market. Yep. And enables the applications to adapt readily without having to replumb everything in order to take advantage of new data or new data types, new data services. So again, the focus then becomes not on the infrastructure, but enabling the application development, which really drives, how well can the agencies do their mission. To Rachel's point, you're offloading a tremendous amount of work from analysts, as an example, when you can let machines start doing the initial triage or discovery of relevance of particular data. Well, intelligence is a knowledge-based function. The outcomes are often unique, but the processes that go into it are often very general. So everybody's trying to look for answers. Everybody's trying to solve problems, and our job is to help make that happen.
And the reality is, if those freight trains aren't delivering that data, then we're not processing any AI, and that's for sure. Well, exactly. We've talked a couple of times about health, so I'm going to throw it over to you over at VA, Gil, and give us an example of some activities that are going on over there. One example, if you would, of where you're using this AI capability.
Yes, yeah, there are a number of different examples, really. But if you think about it, it's in the healthcare area, as you were alluding to, there's a number of things, all the way from kind of the plumbing, as Nan was mentioning earlier, to the to actual diagnoses and so forth. So there is, for example, natural language processing that's being used in terms of submitting and processing different forms and allowing people to, and allowing essentially the detection if someone qualifies for certain medical coverage. We're seeing that one as well. There's collaboration with the Department of Energy, also on new AI approaches that are being applied and leveraged for diseases like cancer, cardiovascular disease, and mental health as a currently ongoing as a pilot as well. So there's a number of different use cases going all the way from research to pilot to production use. And what's interesting is kind of like moving that across those different use cases and moving them forward. So yeah, that's kind of
absolutely great use case there. John, how about at Aerospike? Give us one example of where you all have implemented something or been part of implementing something that is enabled part of this ecosystem.
Yeah, I'll provide one example without being very specific, and this is essentially in credit card processing, which is not necessarily related to the federal government, but the intimacy and the accuracy of doing something like that in real time. We have a client that when a business transaction comes in, like you're buying a latte at Starbucks, some guy is standing at the counter, your credit card's in the machine. And this is the thing you might be surprised. A single business transaction has to go full circle in 750 milliseconds. So that's the 2.5 eye blinks. And in this particular case, the algorithmic decisioning engine has to decide, is it fraud, is it not fraud? And you've only got about less than a half a second to make that decision. And these are decisions made under conditions of uncertainty. You don't know everything. So this particular client has a massive data store, combs through it in slow, sometimes glacier speed to find nuanced relevance, finding intelligence that then you can push back to the edge to make it actionable. So when that business transaction comes in, believe it or not, the algorithm does 250 database reads and writes, turns that whole thing around, and in so doing was able to reduce the incidence of fraud by 30x, 3,000%. And it's because they used more data. And in this particular case, they started out with only about 10 terabytes of data under the real-time decisioning engine, and they've moved that up to close to 200 terabytes of data, all being actionable in a split second. And that's a remarkable use of data in this sort of transitioning period of time where civilian and government agencies are really trying to harness the data they have. It's really important stuff.
Wow, that talk about real time, that is quite impressive. Well, we're going to take another short break and we'll be back in just a moment. You're listening to the Federal Executive Forum on Federal News Network.